In this video, we're going to have a brief overview of the unconsolidated-undrained test, also called the UU test. So in this test, the specimen is not consolidated and it is sheared by applying the deviator stress in undrained conditions. So what that really means is the drainage valves are kept closed during the entire test. Okay, so in this test, you have a specimen. You use the same apparatus as with the CD and the CU test. You put a specimen in this giant cell that looks like a permeability cell kind of, and you keep all the drainage valves closed while you are applying the confining pressure, which is sigma 3, and also while you're applying the axial deviator stress that you then add to sigma 3 to get sigma 1. But you keep the drainage valves closed the entire time. So you do not allow consolidation, and there is a buildup of pore pressure, okay? So now, even though the pore pressure is building up, it is generally not measured. So the pore pressure builds in the specimen, but is typically not measured, okay? Now, because of this, what we end up getting is just total stress values, okay? So we're going to say, thus, we obtain total stress values only, okay? So because of this, you're not going to get effective stresses out of this test. You're only going to get total stresses during this test, okay? Now, it turns out that if, quote, identical specimens are tested at different confining pressures, which are, sigma 3 values, all of their Mohr circles will have the same diameters, okay? So it turns out what will happen is, if you have sigma here and you have tau here, if you apply a confining pressure and then you apply deviator stress, which then grows you a Mohr circle to sigma 1. Let's say you do that, and this is your diameter right here. And then let's say you take another subspecimen from that same Shelby tube, because again, you're running this on undisturbed specimens. So that's what we mean by, quote, identical. And let's say you apply a different sigma 3 value, and you fail it again, and you grow this other Mohr circle right here, sigma 1, this diameter will be the same. these two diameters will be the same. So it turns out that for a UU test, all Mohr circles on a given set of identical specimens will have the same diameter. They're just kind of shifted around relative to one another, okay? Now, when you plot this, you will only get a cohesion value. So what you're going to get is a horizontal MC failure envelope. And this high point right here, this horizontal plane, will be what's called your total cohesion value. Okay, now we sometimes call this the undrained shear strength. So C sub T is the total cohesion, and it's sometimes called S sub U, which is known as the undrained shear strength of the soil. Okay, and then phi is going to be 0 because you have a horizontal line here. Okay, so that's pretty much it for the UU test. Now, a special case of the UU test is called the unconfined compression, or UC test. In the UC test, sigma 3 is 0, okay? So for, oops, didn't mean to do that. How do we back out of this? There we go. So sigma 3 is 0. So in a UC test, the Mohr circle starts at the origin and grows outward to sigma 1. And so, of course, here sigma 3 is 0. Okay? Now, where have we seen this before? Well, it turns out that when you test concrete cylinders, you are performing a UC test. There is no confining pressure. There's nothing around the specimen that's giving it a confining compressive stress all around it. So again, U3 is 0. And again, we have this, we'll have this undrained shear strength or total cohesion S sub U. Okay, now what is S sub U equal to? I mean, the same thing here. If you notice, the undrained cohesion, or the total, or the undrained shear strength, or the total cohesion, is equal to the radius of the Mohr circle. Okay, so you can see that from our little family of Mohr circles from above. Right here, this C total is just the radius of each of these Mohr circles. It's the diameter divided by 2. Same thing here for the UC test. Now for the UC test, sigma 1 is equal to the diameter of the Mohr circle, obviously, because sigma 3 is 0, and we sometimes call this Q sub U, where Q sub U is called the unconfined compressive strength. Now, what is the unconfined compressive strength analogous to from what you studied before? We'll make a little note here. This is analogous to F prime C in concrete specimen testing. And so it turns out that your S sub U is equal to QU divided by 2, of course, because the diameter of a Mohr circle for an unconfined compression test is the unconfined compressive strength, and then half of that is your undrained shear strength. Okay, and again, right now I'm talking specifically about the UC test. The UC test is a special case of the UU test where sigma 3 is equal to 0. So that pretty much concludes our information on the UU test and then its special case known as the UC test.